Welcome to the video. Today's topic is picking by color. Picking by color is an off-screen rendering technique often used for dealing with mouse inputs in 3D space. So for today's example, we have this chess scene setup that we will be using, and we're going to be looking at how picking by color is used to handle the mouse inputs for this game. For this to work, we're going to have to double render our frame once, like you see here, rendering to the main frame buffer with all of our textures and shading and materials, and a second rendering which is going to render to an off-screen frame buffer where each object is individually colored, and it looks something like this. And we'll use this to figure out what we're clicking on when we handle our inputs for the mouse. Before we start looking into some of the code, we're going to take a quick look at our shaders that we use to render the picking scene. They're pretty simple in terms of what is going on inside the shader. They just have some uniform variables, just passing in the model view matrices of the objects, as well as positions, and the color will be uniform as well, since the color will be unique for the whole object. And we're going to pass this through to the fragment shader, which simply takes the color, but we're going to pass in the flat attribute so that is not interpolated, even though it won't make much of a difference since all the vertices will be the same color. So let's step into some of the code here. So this is our function where we draw the picking scene. As you can see, it's much simpler than our generic drawing scene, which handles all of our shading and our textures as well. So that's what I meant when I said this is very simple shaders. So all we do is the only vertex buffer that we need is our positions. So we're going to grab that and enable it. And we are going to pass in our model view matrix as well for the object. Remember, there's also some other camera and projection matrices that we passed in as well. We actually do that before this function, since they are same for all the objects, so we don't need to do it individually. And then we set the color. So for this example, you noticed that there was a color scheme. So I just encoded the different squares to have different colors. So they this would be 0, 0 on our board, and the saturation increases as we go away from the origin. So that's all I did here, where we set this is the red value of the RGB. We set the red equal to the first position value, which is the rank or the column, and then we offset it by 1 divided by 256, just so it's not 0. That way we don't get mixed up with the background. And then for the rows, we do the same thing, but we use the second position. And then we gave different colors in the blue value for what color the piece was. So it's easier for us to determine looking at it, even though we won't need to be using that when we read the values from the image. And then we can just draw our rays as normal. In this case, the length is the number of triangles, so we multiply that by 3 because there's 3 points in a triangle. We disable our attributes just to clean up what we did before. Now that's all good, but if you realized it, we are still rendering this texture to our main frame buffer. So we're not actually able to use it for any kind of input checking yet. So to do that, we need to create an off-screen frame buffer object, which we are going to render this image to, that we can use to check what is at the position where we click. So to hop over here, we're going to look at this function which just sets up an off-screen frame buffer that we are going to be using to store our texture in. So in order to create a frame buffer, first thing we do is we create a blank texture. What's important here is that we have our width and height specified. We're going to use RGBA, and we're going to pass in null for our texture reference since we want it to be a blank texture. The second part is that we would add a depth buffer to it with this create render buffer. Again, same height and width as our canvas that we're using since we want everything to be the same size. And then we are going to create the frame buffer here. And first we bind it, and then we can attach our texture and our depth buffer to our new frame buffer object so that it can hold this data. So we just connect it here with the color attachment and the depth attachment, and then we check to make sure our buffer is created. So we just do that on setup. And then if we go to our update function, or not our update function, to our render function, whenever we render our elements, we need to make sure to bind our default frame buffer. So we bind frame buffer or null, and we enable our tests, we set our viewport, and update the clear color, as well as clearing the screen. And this is just how I was showing you the pick rendering. Instead of drawing the regular draw function, I was setting these the projection and the camera matrices like I was saying before, and then just drawing the pick for all of our meshes. So this goes to the default frame buffer, And then for the actual one, which we are loading into the texture, we bind our new frame buffer. Again, we just make sure our viewport and color, we want our default color black, just keep things simple, clear that. And then this time when we draw our objects, they will be rendered onto our frame buffer. Now onto the final pieces of the puzzle for the picking. We're going to look at how the input is handled. So in our input file, we are going to add an event listener for mouse down in our canvas. Two things that are important in WebGL is that the y direction for the canvas the positive and negative directions are flipped. So usually y0 is at the top for most graphics programs, and the max value is at the bottom. But with WebGL, y equals 0 is at the bottom of the frame and increases while you go up. So when we grab the client X and the client Y from the mouse event, for the Y, we have to subtract it from our height to flip those numbers so that we're reading from the right direction. And also, we need to get the bounding rect of the canvas, since if your canvas isn't exactly at position 0, 0 of your browser window, that offset will go through your program. And then if it's 10 pixels to the right of the left side, then all your clicks will appear 10 pixels to the right of what you're trying to click on. So we get that position, and we're just going to store in our click position in our input class. And then here is where we check, was there a click? Yes, there was. So what we do is we set up an unsigned int array that we're going to read our pixels from. So here we set up our array, and then we gl.readPixels, because if you remember over here, we use the pick frame buffer last, so that will still be the frame buffer that is binded. For me it works, but you might want to make sure that you bind the correct frame buffer before you do gl.readPixels. And then we take that position that we read in here, the input.click position. It's for the x and the y. And we're only going to look at the single pixel that we clicked on. So this is the width and this is the height. It is 1 and 1. It's going to be our GBA value, which is why we have 4 positions in our array. Unsigned int 8, and the pointer to where we're passing it into. And then these two operations here just kind of reverse what we did to pass in our color values, since WebGL is expecting flow values between 0 and 1, and this unsigned int will give us values between 0 and 255. So that's just to reverse what we did. As well, grab the color value. I didn't actually end up using it, but it's there anyways since we have that extra value in our color. And then from that we have the file and the row that we clicked on. Either if we click on the piece or the square, we'll both get the same value. And then from there we can call our select piece in our game function. And there you have it. Then the select piece function will go into our chess class, and it'll see if there's a piece on that square, which it'll select. And or if it's a place you're going to move to, it's going to move you there. And that's how we handle the input with using picking by color in WebGL.